Ladies and gentlemen, firstly let me introduce myself. My name is V.BARAK and I would like to speak about effects of episodic point source pollution on survival of caged juvenile freshwater pearl mussel Margaritifera margaritifera. The effects of contaminants are traditionally considered one of the main reasons of the global decline of freshwater mussels, including endangered freshwater pearl mussel. Their early life stages may be particularly vulnerable, however studies on the effects of water pollution on freshwater pearl mussel are rare. In situ field exposure with subsequent evaluation of species performance is often used in conservation biology and provides valuable information on the environmental quality and site suitability for endangered species. Nevertheless, this bioindication method is still relatively underused and has only rarely been used to determine the effects of episodic sources of water pollution. In our experiment, we studied a declining freshwater pearl mussel population in the Malacological River, reportedly disturbed by the impact of point source pollution. Modified gradient design method was applied by delimitation of the impacted and both the upstream and downstream control river sections. 4 study sites were situated within the impacted section, and 5 and 6 control sites were located upstream and downstream of the impacted section, respectively. Juvenile freshwater pearl mussels within the second growth period of postparasitic stage were exposed to river conditions in open water mesh cages. 22 to 24 individually held juveniles per locality were used, resulting in the total number of 342 juveniles housed in 42 cages at 15 experimental sites. 5 water samples for chemical analyses were taken at each experimental site during 1-month experiment from July to August 2019, and water temperature, conductivity and dissolved oxygen were also measured. As it had been assumed, survival rates of freshwater pearl mussels within impacted section were lower than at control sites. 73 to 95% and 91 to 100% of the upstream and downstream control values respectively. Numerical values of organic load indicators were higher within impacted section than in both control sections in case of ammonia and nitrite, and lower in case of dissolved oxygen, indicating a significant effect of pollution input in the impacted section and its subsequent elimination by self-cleaning processes. An acute effluent-induced toxicity could be detected within studied river. This study highlights the importance of freshwater pearl mussel sensitivity to sudden adverse changes in ambient water quality, as indicated in the study by Cherna et al. 2018. The methodology applied here may provide a useful tool for assessing and managing water quality within freshwater pearl mussel streams and possibly other freshwater mussels. Thank you very much for your interest. If you have any questions, please let me know. Here you can see other contact information.